what we're doing today is we're looking at a brand new model for computer vision called SAM3, and I'll explain what that is. And it's called the Segment Anything model. It's the third version, and it only came out at the end of November. And if you if you have social media like mine, I only really browse X these days a little bit. It's not like it used to be, but it's filled with um, artificial intelligence stuff, my timeline. And it's been particularly crammed with this particular model because it has really excited people about what it can do. So I thought I'm interested as well, and it overlaps with some of my research interests. And but I've done things in a different way in the past with computer vision, and this is a whole new ball game, and it's so much easier. Christmas, happy Christmas, everyone! This will be our last meeting before the new year, and then we'll meet back again um, in the 13th of January in 2026. So I'm looking forward to that for meeting 199. But for today, if you want to follow along with the slides, if you want to link to the GitHub files, which might be interesting to some people, and we'll have a look together at the official SAM3 GitHub repo. And then what I'm going to attempt to do is go through a talk to give the background for people who haven't thought about this kind of stuff very much before. And then I'm going to look at the resources in case you want to dabble at running it yourself. And finally, I want to use the last bit to attempt to run one of the tutorials from the official repo. There's a little bit involved if you were to want to do that yourself, but I'll talk you through that, and I've made some very minimal instructions on my own GitHub repo for you, which we'll look at, and I'll talk you through how to do it, and we'll see if we can get through it. I haven't actually run through it myself yet, because when I asked for access to a particular resource, I'll highlight that when we get to it. Um, I think I made a mistake and forgot to hit, submit. And when I went to do it today to just make sure everything was working, I didn't have access. And so I requested access again, and they did grant me access just not too long ago, within the last couple of hours, and I haven't been able to go back. So that's what we're doing today. And with that, I'm going to go ahead and start with the slides. So I mentioned the SAM3. This is called the Segment Anything model, and it's the third version. Now, it's been around for a few years, and it already was a really good computer vision model that was popular, and people were using it for important questions. And I'll go through some of that and tell you who is involved in that research and so forth. So we're going to talk first, though, about what is segmentation, what it's meant. And it's a kind of artificial intelligence in a field that generally is referred to as computer vision. Kind of things that I've done with computer vision in the lab with students are things like, with George Wager, looking at profiles for cattle feeding. I've looked at doing species identification with moth traps from computer images taken from light traps outside, and a few other special applications. Probably the biggest one that we worked on and talked about a lot a few years ago in the lab was the tuber meristem identification to count the productivity of tubers and to predict spatially where the distribution and size of tubers were based on characteristics of those tuber meristems in potato. So I have done quite a lot of work with different models, but I've never worked with the SAM model. So we're going to explain exactly what SAM3 is, why it's special, and then go to the demo as quick as we can to see if we can get through it. Now, when you delve into this world of computer vision, this is one of the more mature areas of artificial intelligence research. Now, I might mean by mature 6 months ago, because things have been happening so fast that things just 6 months ago are completely bypassed now. In large language models, that's true. In computer vision, that's not true. There were some really big breakthroughs that happened starting about 20, 25 years ago, even further back, but really big breakthroughs. One of the biggest ones was identifying hand-drawn numerals from a data set that now is famous by relatively famous people. I'm not going to get into all the detail of that, but it was very, very accurate, almost as accurate as humans were at identifying hand-drawn numbers. Now that's pretty good, and that breakthrough happened, a couple decades ago. Some of the people involved in that research have quite recently won the Nobel Prize for that research. So this has its foundations in the very big beginnings of what we now just refer to everything that computers do almost as AI. But AI is a big field, and computer vision is a specialized part of that field, and image segmentation is yet even a subset of computer vision. Now, what do we mean by image segmentation? Well, turns out there are different types of segmentation. It essentially is classifying images for the content of the image. And one of the oldest types was just called semantic segmentation. And here, you see this picture of a cute kitten on some grass with some trees and the sky in the background. And an example of how semantic segmentation would work, what this does is it takes every pixel in an image and it applies to it a simple label. Now you have to train the labels for pixels in semantic segmentation and other kinds of computer vision I have on this slide with a lot of examples, a huge number. And what it's using to make those classifications is the particular values of no problem, Juliana, see you later, is the particular values of the red, green, and blue content, the illumination, the brightness, and maybe even some other characteristics in some kinds of images. And in this one, the classifications that are made on each pixel in the image are things like grass, cat, tree, sky. Okay. The kind of computer vision that I have used in the lab are these two in the middle here, classification and object detection. And with classification, as a matter of fact, mainly object detection is what I have used. With classification, you get a localized box that identifies an actual object that has been trained upon. And the way this works, we're not going to go into it, but the way it works is it's not just a single pixel, but there are different layers, as they're referred to by practitioners in the model. And some may just be pixels, but most of them are groups of pixels that form edges, that form shapes. They might be as little as the edge of a whisker on a cat, or they might be as big as an animal eye. And there can be other ones as well. So what classification and localization does is it draws a box around a group of an ensemble of features that the model's been trained on and localizes it. Usually it's associated with a probability of that detection too, which is nice. Object detection does the same thing as classification and localization, but it does it with multiple objects, and it can identify objects of different classes as well. And then finally, and also the classic object detection, the kind that I've used a lot, it still just draws a box that bounds. In fact, they're called bounding boxes that bounds the object that's classified. And you can see in this picture, this is kind of a nice picture because you can see it's not perfect. For example, this box on the dog wearing reindeer ears, this box comes out to the side. There's no box, there's no dog at all out here to the side, but the box is imperfect. And so that's a feature of this kind of detection. And then a fairly newer version of segmentation is instance segmentation that identifies all the pixels associated with that object in the class. And the idea here is that it's more accurate in a sense than the bounding box. But the real reason instance segmentation was developed is so that you could mask and alter objects in the image. And I don't have an example to show you, but an example of that is like she usually come up in a poor context or a bad light in the popular media. But it could be to include the tail. You could be right. Maybe also the cat over here. I can't quite see the tail from this picture, but could be. But there are errors with bounding boxes. Anyway, there's a lot of space here that doesn't contain dog. I guess I was just trying to distinguish it between instance segmentation and object detection, but good catch on catching the tail. But the dark side of instance segmentation that we usually hear about is something called deep fakes, where a video, which itself, of course, is just a series of images, would be masked like this. When you do an instance segmentation, it sometimes is referred to as masking. And then you can superimpose your own image into the mask. Now, this, like I said, the deep fake kind of applications are a bit weird and bogus, and definitely have a bad reputation. But there are some legitimate uses for this for entertainment. Even some of those are controversial. We only hear about the controversial ones, but you can create new media using this, which is the idea and the spirit in which it was created, something useful. Oh, click there, but I meant to go down. Yeah, so one of the biggest innovations in computer vision has happened very recently, and I don't mean 6 months again. I mean in the past. What I want to introduce here is the idea of transformers. And as you'll see in a moment, transformers have been around for about 8 years. They were invented about 8 years ago. So by AI standards, they're ancient technology. But computer vision transformers are relatively newer, and they've only really been making a lot of headway in the past few years. And so I want to make a contrast between simple neural network computer visions and transformer-based computer vision models. Now, the neural network version is the classic one. I'm not going to go into what neural networks are. I've mentioned a few jargon terms already that I didn't want to mention, like layers in an image and things like that. But essentially, I do want to mention a few of the features of this old-fashioned approach that's rapidly being completely replaced by transformers. One of them, and this is the version that I've used exclusively, the old-fashioned neural networks, they have a reputation for being very accurate and very fast. And one of the foundation models that I have used quite a lot is called YOLO. That doesn't stand for you only live once in computer vision. That's a famous model that stands for you only look once. And what that means is that for a lot of these classification models, you would do different passes. The model would look at the image multiple times and look at each box that it draws multiple times to look for those features for classifying objects that it found in the bounding box, and in fact deciding on the best bounding box, the area of greatest overlap in the bounding box. So the old-fashioned ones were they were still very accurate, they were still very fast, but they got better, and they have a reputation now, especially models like YOLO, where you only do one pass on the model and it's still very accurate. They're much faster, and they're so easy to use as well. A downside of them is that they require lots and lots of training images. In the old days, with the hand-drawn image classification data set and all the ones that followed, ResNet is one of the big famous ones that I teach with a lot, and we've talked about a lot. Well, not a lot, but a few times in Herrig over the years. They are comprised of tens of thousands of images, and the way people usually use these is they download not the images, although you can still, look up the research papers for these data sets and download the data sets. Many of them, even though there are thousands and thousands of images, are fairly small because the images are themselves are not very high resolution. They're the minimum resolution to create the features data set. Anyway, instead of downloading the images, you what you might do if you want to train your own model for classifying new things is you might download the weights, and that's a statistical summary of the predictions that the model's capable of. And then you use a relatively smaller number of images to use the primordial features contained in the weights to create new features that are very specialized, just very fine-tuned features for your problem alone. Now, that's the way that I have used these models mostly. And to give you an idea of what that means, I think for TuberScan, I think this was before your time, Jimmick. I think we had done that work before you joined the project. And unfortunately, that was the most fun part of the whole project. So you joined at a more difficult time, let's say. But I think we had around 2,000 images, and each image had about 5 to 10 tuber plants in it, and each of the tuber plants had somewhere between like 3 and 6 meristems, and all in we had around 10,000 bounding boxes that we hand created to create our own fine-tuning training data set for a YOLO model. So that just gives you an idea of what I mean by requires lots of training images. And then finally, these models tend to have fixed classes, so that the model that I made for meristems with George and Matt Butler, that could only identify potato plant meristems, and it wasn't even perfect if you did varietals of potatoes that were very different from our training data set. We only had a few varieties in our training data set. The moth data set that I did, I think I trained one with a student that had about 100 classes of moths, and at any one time, we would draw out the weights just for the top 10. So we were only ever looking at about 10 at a time. So you not only do you have fixed classes, but you were limited. The more classes you have, that just amplified numerically how many training images you have. So there is a real world constraint in that. Fast forward to today, one of the reasons that transformers are really sweeping the world and the industry as well is because they're just better in every sense. And just to highlight that, they're much faster. They're called zero shot. I mean, it just reads the image and it makes the prediction, and it's just as accurate and even more accurate than the old neural network models, and much faster. There are no training images needed, assuming you're starting with a foundation model, because it draws on just the weights that contain a very large array of features, and it assembles the array of features based on its experience, and it can assemble new features in real time. This is amazing. This is astonishing. And it's one of the other reasons why people are so excited about it. But probably the best reason for it is that it also drops the requirement for needing to define fixed classes, having rigid classes. You use natural language. I want to get every person with a white shirt in this sports stadium. I want to get every red car on the motorway. I want to get every animal in these series of trail camera images. You use natural language to make your queries, and it assembles the features. So even though the technology is similar, even though the outcome and the predictions are similar, they couldn't be more different. And it's a big deal. This will affect your life indirectly or directly in some way, I predict, for almost every person. Now, I just wanted to highlight a couple of things for people. I mean, I like to do this, but I know that I have an old-fashioned view on this compared to younger people these days. But I did want to tip my hat to the Transformer paper that changed everything. And mainly, this is referred to for large language models and what we call AI today, like ChatGPT and DeepSeek and the others. Um, Transformers were only invented, were only really released to outside of a very small research community in 2017. And they were released as a conference proceeding by um, researchers from Google at a conference. In fact, this conference just happened a few weeks ago, the one for this year, obviously. It's Neural IPS, Neural Information Processing Systems, the NeurIPS conference. And they tend to, big research groups tend to save their biggest stuff and make a big splash here. And of course, they have a research prerogative to want to release their big work at big conferences where their colleagues and peers are. But there also is a business perspective on this, is that the newer IPS is a big place for what they call these, well, investors in industry that will capitalize on these research findings, especially if they're made open. This paper is a really, really big deal. It's such a big deal that I would proclaim that any scientist working today in any field should be aware of this paper. Why do I why do I make such a bold claim if you're not working in computer science or AI or something else? Why do I boldly claim I think you should be aware of this paper and know why it's important and essentially what it says? Well, one trivial reason is that it has been cited 207,980 times. I don't know of any other paper that even comes close. And if any of you know of any papers that have been cited more than 100,000 times, please let me know. I'd like to read them because those are important papers. This paper has changed our society. It will continue to change it. It has changed higher education and lots of other fields, which I'll give you a few examples here in a second. I put the picture of Ilya Polasukin down here at the bottom because he's, even though back then he was a scuffed postdoc in doing an internship or something in Google. I say that disrespectfully because he's a one of the brilliant minds today doing this kind of work, and he's maintained that position. And his current project, which I think is very important, builds on his earlier experience in research, and he's working on personalized, private artificial intelligence systems that keep your data private. Of course, this has big commercial ideas, but the thing I really like about Polasukin is that he espouses this philosophy that he's driven in this for ethical reasons. For example, for you to be able to research and explore your own private medical health records, for you to uh, receive legal advice in a confidential way, and other applications. So this is, yes, that's exactly right. Transformers are a big deal. Um, anyway, enough about Transformers. I'm not going to go into what the any of the technical detail. We don't have time, and this isn't the place. But essentially, the big change that it's made from neural networks is that it created a technical mechanism that, in the course of a prediction that takes more than an instantaneous moment, it created a mechanism for memory, and they referred to that mechanism as attention. And that's the source of the title of the paper. Attention is all you need. And awareness of this in something called data science, because now these days a lot of people refer to themselves as data scientists, but appreciation of transformers really separates people who know and people who really don't know what they're talking about. So we look at some applications. One of the first times I encountered computer vision, and this is an image of the layers in a convolutional neural network. We can ignore all the detail here, but this application is just one of literally tens and tens of thousands that takes an input image that might have a weed in it and then segments out the weed to make a prediction about where to spray in a field, pairing it, of course, with geospatial information. Another application, one that we're interested in the lab, although we have been slow to get it up off the ground, especially in this last year, is, for example, reviewing camera trap images. If you've ever worked with camera traps, and I've worked with them a lot in my past career in various applications with different students, these images that are cherry picked are kind of easy because they have obvious animals in them, and the animals stand out against the landscape. And, you know, in most of these cases, if you know anything about the time and place, and if you know anything about animals, wildlife that is, you would be able to identify most of these animals. But human error comes into this. That's one thing that comes into the identification of, say, doing biodiversity monitoring and automating it so that it doesn't take huge amount of time and resources, not just the money to put out the hardware. That's the small part. It's the human endeavor of placing them in the wild, going back, getting them, and then coming back with the images. Well, first, you have all these images, and these are cherry picked for high quality. You have loads and loads that are much lower quality. Of course, even the low quality ones will have features that humans may not recognize. You know, we only recognize ensembles of features, and these computer vision models recognize subtler ensembles, smaller ensembles. Another thing is that there are a massive number of these images if you're successful at getting shots. And I don't just mean hundreds, I don't mean thousands, maybe not even tens of thousands, depending on when and where and how long you leave them out. I studied a species with a PhD student in Kenya called the mountain bongo. And we estimated at the end of the study that there were only about 135 total animals. That was the point, one of the points of the study, to estimate the total population size for the first time ever in the history of studying the animal. Even though there were only 135 individuals, we estimated that. We didn't take a picture. I think we estimated we got 85 unique individuals, so more than half of every animal that's living in the wild. And we used as a training data set animals that live in zoos. And it turns out that species thrives in zoos, and they've been in zoos. They're beautiful. The mountain bongo, Google it up if you haven't seen a picture. Unfortunately, I didn't add one to the talk, and I'm not going to take time to look one up now. But more of those animals are alive in zoos than live in the wild. So it was relatively easy for us to train the data set up. And the last thing that makes it nice for a problem like this is that you get loads of images with no animals at all. And they just take time. It still takes a human time to look at those images, but an AI, a computer vision model, can pass over them almost instantaneously. One that, I have experienced health-wise is using artificial intelligence to identify pictures for predicting medical conditions. I have experienced this only for eyesight. So I take that little bit of an extra test to look for glaucoma. But, you know, they're using this to predict cancers is a big one, including all types of cancers, lung, colon, skin, everything. This is a big deal. We hear about it in the news almost daily. I'm not going to bear on that. It's self-evident. One that we probably have all recognized already has its roots in that famous Nobel Prize winning foundation of computer vision, and that's the automatic recognition of car license plates that give you a fixed penalty notice. Maybe the bane of your life, but it has created a lot of industry, and it has automated something that was not automatable in the past. SAM3. Now we're just kind of going and skimming over the ground of this. And I wanted to highlight this paper in particular because it's a future classic that will be cited many, many times unless it's superseded very quickly by SAM4, which I doubt it will be because it's created such a big splash and it works so well that people are going to work with it for a while. Now, this is the segment anything model. And this paper came out, it was published like a lot of these papers in arXiv, an open source preprint factory for cutting edge research. And there are arXiv style repositories now in most research fields. This, as you can see in the title of the paper, was produced by Meta, the company that owns Facebook, WhatsApp, and others. And they do a lot of serious, hard-hitting AI research, even though we don't think about that. They're doing primary research. We hear about ChatGPT a lot and some of the others we talked about in past weeks. But a thing about Meta that I really like and I wanted to highlight with this is that they have a commitment, unlike ChatGPT founder OpenAI, the company OpenAI. They have a name that connotes being open, as if they're making their model to benefit society and they're releasing those weights for anyone to use, but they're not. It's a paradox in their name, and they're heavily criticized for it. Meta, on the other hand, a company that you might view as the faceless, consciousnessless company out of California, out of Trump's America, that's in it for the profit. They have opened almost all of their primary research for society to use as they see fit, and for example, for medical research. This paper is a big deal, a really, really big deal. Look, it was only published on the 20th of November, less than a month ago. A lot of people involved in this important stuff. I just want to highlight you with a few things over here, and there's a lot going on in this image. Let me just draw your attention to this left-hand column here. We've got an image in the top row. We've got predictions, segmentation predictions from SAM3 in the middle row, and we've got OWL version 2, another open, very accurate prediction model that they compared predictions from SAM3. Why didn't they predict against SAM2? Because OWL3 version 2 is better than SAM2. This is a picture where they prompted with the words a white flower, and you can see a structure here with some small white flowers, and you can see SAM3 segments out the individual flowers, but the OWL2 gets the whole structure and misses the detail. And this middle one, this would be like a weed or agriculture application, maybe a harvesting application. You see a not very good picture of a misting of some young plants in a grow box. And you see the neat lines of segmentation for SAM3, and we're missing a lot of plants in the mist primarily. Amazingly, they're prompting this with the prompt young plant. And look how accurate SAM3 is. Have a look at some of these. It's just astonishing. Not only that, these haven't been trained on young plants. This is a prompt that is assembling features based on semantic training for the words young plant associated with the pixel-based features in the training data set. You can see that I'm a fan of this kind of stuff. I see the value in it. I'm excited by what it can do. I'm not going to go through the rest of them, but you can see the potential here. This is an amazing model that, again, I think will change the world we live in. I think it's that important. If you like to read, here are some of the citations for some of the things that I did, and some, this book rather in particular is one that really inspired me to start using computer vision in my research a while ago. I read it pretty close to when it came out, as a matter of fact, and it took me a few years to shift my research to incorporate these tools, but it was worth it, and I still have a soft space for it. It's very clearly written and accessible to all sorts of scientists. And of course, the other research papers that I mentioned. We're going to look at some code now. Now, if you go back to go back to this page and you want the links to follow along, you needn't follow along. I'll walk you through it. We're running out of time quick here, and I have a bad feeling that we're not going to get through all of this code, but I want to at least show you how you can tamper with it yourself and play with it yourself, and how to get it started so that you could, if you were so inclined, to do it in the easiest way possible. The first thing I'd have you do is look at the files link, which is my own repo for HADC. And what you'll see is this link. And I'll just drop this link in case you like to bookmark things. There you go. And I've made this little bit of a README. And what I'm going to do is I'm going to go through one of the examples on the official Facebook/Meta. It's on a account called Facebook Research, which is Meta's artificial intelligence research account. And for the open stuff, they publish repositories up there. We're going to look at the SAM3 repo, which was just released, literally less than a month ago. That's the link to that. Have some notes in my own experience of trying to get this to work. An essential thing is that you need to read the SAM3 README page, or you don't have a hope of doing it, no matter how good you are at Python programming and AI-related topics. Having said that, you don't need the method I'll show you today. You don't need to be able to program whatsoever in Python to be able to run this. It's the beauty of the world we live in these days. You will also need to look at it will prompt you, as a matter of fact, to request access to something called Hugging Face assets. What is Hugging Face? Well, Hugging Face is kind of a big deal in AI. It's a platform not just for creating instructions and repositories for demonstrations. Usually models are hosted on Hugging Face, but it also gives you the ability to run those models and to test and run the models that other people publish on there. It's amazing. They have a lot of free education resources on there too. You do have to pay to spin up your own instance, but you don't have to spin up the instance to do this. So you can do this and many, many other things on Hugging Face for free. One of the things you can do for free is request access to the Facebook model. Facebook pays, you just request access to it, and they're just collecting analytics, and they require you to ask permission. It took them about 2 hours to give me permission once I did it correctly. So you need to have prompted the place where there are Hugging Face instructions at this link if you want to read those. Now I'm going to use Google Colaboratory to run this. I recommend you doing it too. We're going to run into some problems. I'm going to show you in real time the problems with using Colaboratory, and I'll explain why we're having problems, even though this is a pretty new model, and I'll explain to you how to get past them. The easiest way to use Colaboratory is to copy this link, which I'm going to do right now. I'm just going to, now, you probably won't be able to follow along with me unless you already have access from Hugging Face for this. So, pay attention to what I'm showing you. You can come back and try to do this later. The instructions, you have to read them carefully, but they're actually easy to follow, and you don't need to do any programming whatsoever to do what I'm about to show you. You can run them other ways as well, and I highlight those. And I'm going to run, probably, if we're successful, most or all of this notebook. I wanted to run the video one, but I realized it would take too long. So we'll see how far we can get in this simple image demonstration of SAM3. So to do that, I've copied this link, and I'm going to go to the page colab.google.com. Now, if you haven't used Colaboratory before, when you open it for the first time, and there's the link, it'll probably look like something like this. Now, there is a bit of a prerequisite, a bit of a prep for this as well. It all sounds a bit troublesome, but believe me, it's very easy, and it's the easiest way to have some insight in this stuff if you're so inclined, is to have a Google account. And you want to be logged into your Google account before you go to Colab. And if you're logged into your Google account, I'm using the browser Chrome. That's native because that's the open source browser that Google supports. Everything works absolutely perfectly. I can't vouch for others, but I know Firefox and Opera, which I also use regularly for different reasons, both work swimmingly well with Collaboratory. When you open it like this and you're logged in, what you get is a page like this. And if you don't open it from a notebook link, and because I'm opening somebody else's notebook, I chose to open it and to show you how to open from the link. Here's what you get. And this is just the open notebook page. What do you get by using Collaboratory? What is Collaboratory? I'll mention it because we haven't used it in here in a little bit of time. Collaboratory is a virtual server that's very easy to use, that has snippets of code in blocks, and it provides you for free for pretty robust usage. As you'll see, we're doing something that's pretty serious here, and we'll probably be able to accomplish it in the next 15 minutes, is that it gives you a free virtual server that you can use. There are limitations on it, but it's very generous. It's ridiculously generous for free. So you have some choices here. We're going to open one. There are some examples you can run. There are recent ones that I could run. And I don't use Colab a lot day to day. I use my local machine and I use other solutions. But for teaching and for playing around with something fast without having to set up everything from scratch, there's nothing easier. You can do it from your Google Drive if you have a notebook. And finally, you can use it from GitHub, or you can upload one. I'm going to use it from GitHub. I'm going to let it think. It's picking up my repo, but I don't want my repo. I want to paste in that link that I did, and I want to search. Oops, that's the wrong link. I copied something after I copied the link I wanted. Let me go back to the files here. This is the link that we want. That's the github.com Facebook research /SAM3. That's the one we want. There we go. So it's thinking, and what it's doing is it's scanning that repository for available notebooks, and it's going to come up with about 7, 8, 10 of them that are examples on that repository. And then we're going to open one. It's taking a bit longer than it should, but let's just be patient. We're going to have to wait a little bit for this to play out because some of the steps will require corrections. There we go. It found it. We're going to scroll right down to the bottom. You can view, you can open in a new page. We're going to do the image predictor example one. And it's going to think about it for a second. Now we have an interface here that's got kind of a lot going on if you've never done it. There's a menu up here, drop-down menus. There are some sub-menus here where you can save a copy of this notebook we're running in Drive. If you haven't encountered one of these notebooks before, you'll notice a couple of things about it. One thing is that there are boxes like this one with a little triangle, a little start button that are meant for code. And then there are some boxes like this that are markdown that when you click out of them, they render as markup text, so attractive text. And this combination of having the code in the virtual environment and the explanatory text as comments that's formatted is brilliant because it's really good for teaching. And because it's good for teaching, lots of students for the past decade or so have encountered this kind of environment, and Google Colab is one of the easiest ways to use this. So I'm not going to mess about too much, but I do need to make one adjustment before we start, and we need to be a little bit careful, and I need to remember the things I need to do to be successful. First thing we need to do is to go to the Runtime tab. Now, a lot of AI these days, you've probably heard of CPUs and GPUs. That's Central Processing Unit and Graphical Processing Unit. for fast AI and for some of the libraries that most AI uses, we use graphics processing units, GPUs. But Google doesn't just give you a GPU environment for to start off with because not everybody needs it. And they're more expensive, more complicated. So we're going to change the runtime type. You, by the way, can pick Python, R, or Julia in the runtime. We're going to stick with Python. And we're going to pick a T4 GPU. You don't even need to know what that means. I only have 3 options on my free account. I have paid for Google Colab on a pro account in the past, in which case you'd get access to all these different options. Every option except CPU is a graphics processing unit that's made for AI, essentially. Of course, having said that, I've just told you that GPU stands for graphics processing unit, but my only other option here is TPU. What the heck is that? We hear a lot about that company NVIDIA these days. It makes graphics processing units. They used to make video cards only. Now they make AI processing chips. A TPU is a tensor processing unit, which works exactly like with different details as a GPU. And the TPU is a Google invention. So this is native Google chip. And anyway, we're going to pick the T4 GPU. And we're going to hit save. And we're going to see over here that we need to connect to our T4. So we're going to connect to that. Once we're connected, we go. Fantastic. We can kind of see what we've got in our resources if we just want to look at it. We've got 12.7 gigs of RAM, 15 gigs of video RAM or GPU RAM, and we've got, well, this is connected to your Google Drive. So, 15 gigs if you're on a free account, or I pay a little bit each month. I've been using it for very, very, very long time. So I'm going to close that and I'm going to start running these. Now we're using Colab, so I'm going to put this to true and I'm going to hit Shift Enter. And this asks me, do I trust this notebook? Well, if you run any cell on here and it's doing a lot of code and you don't understand the code, yeah, it could do some nefarious stuff. But I completely trust Meta. I'm not really, but the code we're running is relatively simple today. So we're trusting that, and we're going to take responsibility like people, like real people, to run this stuff. I'm going to go ahead and go through this as fast as I can, and we will probably hit some errors. This is a block. I noticed the comments are not very good. I'd mark down my own students. If I had them, I'll try to explain some. This is loading up a computer vision toolbox called PyTorch, an accessory toolbox to PyTorch called Torch Vision, and CUDA is using that T4 NVIDIA GPU, and it's a toolbox for that. So it's downloading in that stuff. It said a lot of it's already satisfied, which is good news because we know it'll work if it is. So it's just scrolling. And is it finished? At the top of the cell, we can see a little green check when it's finished successfully. We're looking for errors. There are none. These are just importing libraries and tools. I think we're going to get, see if this runs successfully. I think it will. So OS is some tools for file handling. Yes. All right. So I ran into this before. I want to show you a trick, and I want this to be accessible for anybody who wants to play. We're basically getting a few libraries that aren't found that probably are dependencies of these other libraries. And this is the biggest pain for doing any programming outside of R. R is relatively safe and easy compared to Python. But Colab has built in Gemini AI now. And I'm going to open up the examples. Oops, I'm not going to open up the examples. Instead, I'm going to explain error. And Gemini will pop up, and it's going to give us an option whether, if it can fix it, inferring from the error what went wrong. It's going to give us the option to accept and run the changes. And it's going to add a line for installing that package dcord, and we're going to get another error because it still doesn't have the other one. We'll see if we eventually get the other one. It is sweet. It's so sweet. This is a thing that even frustrates me using Colab, and it really frustrates me on my own system sometimes. Um, so that seems to have completely run well. Let's go up and see. We got the green check. Yes. If you don't get a green check, you get a little error like this. So, oh, let's run it again here. Scroll down and see if it. There we go. Did get another error. Oh, and it's just the other one. I scrolled up too far when I was looking at the fix. So this should fix. Hopefully, it fixes both of these. Let's fix and run. And it's finding another one that it doesn't like, so it's working and it's thinking. When you're working on your local computer or you're working on an environment, that one of the downsides of Colab is that you get it for free, an upside. One of the downsides is that it doesn't persist. So if you take the time to set up and work through all these problems, you really need to save your work in the notebook. So then you have to go through it again. Let's see. So it looks like still got another error. Going to accept and run. I came up with a fix to install something else that was a dependency. So this is to do with one of the machine learning and data handling packages, NumPy, SciPy, SK image. All of these are very popular ones, but what's happening here is that the version of the repository we're trying to run has very specific requirements for all these libraries. And R is completely unanimous in the versioning, and it's very strict. And it does it 4 times per year, where it forces every library to update it exactly the same time. But there is no such dependency for Python libraries. They're constantly in real time, all changing all the time and mutating. And so you have to get the dependencies perfect. Because this is a moving target, it's under extreme development in the past, 3 weeks or so. That's why we're getting these errors. We just have to bear with it. We may run out of time. We still have a few minutes. Once we get through these installations, the rest will run and we'll be able to get the payload at the end. Okay, so this is also reinstalling the scikit learn library to get the versioning correct. I really like this implementation of Gemini, and I actually hadn't used it until a few days ago on the weekend when I was looking at this for the first time to prepare for today. It's a brand new feature. Gemini, as I mentioned, I think last week, is generally considered the most accurate, best coding model now for AI like this. May not be the most popular, at least not yet, but it is considered on those leaderboards to be the most accurate at the moment. And this is just amazing that they are giving it away for free in Colab and other places. You can use it pretty generously compared to a lot of the other AIs for free. There's something amazing happening now that I want to highlight too. So that worked, and it seems to be clicking us up. So so that worked. So I'm going to move on to the next one, and I'm going to get rid of this box. So no, it didn't. Okay. So the current NumPy installation fails to pass simple sanity checks. All right, so maybe this is the last one we need. No, it's still doing that. I think this is going to be the last one, I hope. I remember having to do this a number of times. So I wanted to demonstrate this as well. And also, it's very difficult to record and change save changes that I could share easily with you guys. And I was figuring it out. I wasn't able to run it completely before the thing because I only just got permission from Hugging Face, which we'll see if I solve that in just a moment once we get past this cell. I did get past this cell before, accept and run. So now I've done that a number of times. I think this one renders successfully. I don't know why it's popping me back up here. I just want to run it one more time to make sure that it is not a dependency for the next cell. I'm just going to make this a bit smaller because it's hard for me to go through the windows. We don't need to look at all this text anyway at the moment. I wanted to highlight that it's doing something amazing if you read this text, is it's downloading a very large amount of stuff very quickly. And why can it download it so quickly? Because as I've complained sometimes in here, I live in a very remote place with terrible internet. It's not downloading it to my home. It's downloading it to, okay, that seems successful. We're out of time. I'm just going to persevere with this a little bit more. Okay, and explain the error. And if you can stay, please stay. I'll keep the video running if you want to see if I can do it home. I'm going to give myself about 10 more minutes for working this out. So we're looking for a module in the library NumPy called numpy.care or numpy.char, as computer scientists would say. Let's see what it comes up with. There's a version conflict, so I'm going to yet again go with another part of NumPy. NumPy is one of the big, really popular modules, and if there's some dependency of a really important thing, NumPy always will immediately respond, and I think that's probably what's happening here, that there's some dependency for SAM3 that has been a very recent change since this notebook was published by Facebook Research. Hopefully this goes through it. Did get through this cell last time for sure. I've just done the same thing I did before. Hit the wrong one because for some reason it's flipping those cells. There we go. This is the correct one for the error we're working on now. Haven't noticed that cell flipping behavior. What it's doing is it's clicking up to the previous successful cell, and it's hard to keep track of because of Gemini. But this is definitely the right one and the current error. So hopefully this will work. But as I was saying, if you set this up locally, you only have to set it up once and then you're just set unless nothing changes. Okay, so it's come up with a solution, and I'm going to accept and run that solution. I have seen this text before, and I remember seeing the 1.26.0. So hopefully that will do it. Looks like for some reason there are two cells that have the same thing, which I'm not sure what we're seeing here. I'm going to go to View. I'm going to go to Runtime. want to get rid of the output so it's not so confusing. We're still having that error. I'm just going to try to try that one more time before I give up. Almost to the good part. If we can just get through these, this is all environment setup. And for people in the know, doing this environment setup part is by far the most difficult part. I'm going to go ahead and accept an auto run. Okay, this is something new, so that's hopeful. Just going to scroll up to look at the status here. We're working here. But anyway, if you download this stuff locally, you only have to do it once, but things tend to always change. And so you do get marginal benefit unless you're really doing this stuff a lot by setting up virtual environments locally. And it is, as I say, the most frustrating part. It's really nice that I'm not sure I finished explaining why it's so fast for downloading massive libraries, is that it's not downloading them here, but it's downloading them to that server, and it's usually downloading them from some big server cluster in America, often California, to a big server cluster somewhere in America, often in California. We may be hitting a node somewhere closer to home, like in the Netherlands or in the Republic of Ireland. There are big nodes for AWS that Microsoft and basically the whole internet uses for Europe. But they are just, our requests are just going through that to the node where the action is happening in probably in California, and it might be replicated a few places for resilience. So because it's taking a long time to run the installation cell, it probably is thinking through this. You can see some progress happening down here. Something new just happened and it started a new execution. So things are happening even though we don't get a visual cue. Usually Collaboratory is good about giving you visual cues so that you're not just waiting on the circle of death. But I guess another thing I could say is that it can take a really long time, hours, to set up an environment like this and to troubleshoot and find out what you need and how things have shifted as you're trying to build something or follow an example. So even though we've really only been doing this for 20 minutes, it's nothing. And it's so much easier these days than it used to be. No problem. Thanks for coming. The video will still run at least for a few more minutes before I give up myself. Happy Christmas. Okay, that has finished. Still having something here, so let's see what happens. Still going through the cell. Looks like we're going to have to rerun it to reset it, so hopefully that will work fine. Because I see that stopped, wondering if this is working as it should. Nope, it has started a new execution. Good. Kind of investigate the options. This is pretty neat. I've never seen this interface before. I don't know if I love it, but looks like there's an option for a new chat to make it bigger. Oh, we can move it to a panel. Oh yeah, I definitely like it better in a panel. Okay, that's good. Okay, interesting. Having this AI chat right in Collaboratory is a big innovation. while that's running, I'll show you some other stuff so that we're not just sitting dead. Over here is a place where there's a lot of actions. One I want to show you, so save time later. If I open this, it's a image of a key, and this is called the secrets panel. And to use a lot of online services like artificial intelligence models that are provided by companies like Meta, like OpenAI, like Hugging Face, and so forth, they require you to have an account, sometimes pay, sometimes not. The Hugging Face one is free, like I said. And this one called HF_token is it's in the instructions that I linked to. It's a secret. It's my own personal secret. It's hidden from you. You can't see, but we'll run a cell in a few minutes that gives access through my Google authentication encrypted account to my Hugging Face token, which I put in the secrets pane to prepare for today. It's part of the preparation. And I have one for ChatGPT from OpenAI. I have one called RoboFlow. I've had others in the past, and I just take them off when I don't use them anymore. I don't need them. But using these secrets is, you essentially have two choices. You have to use some encrypted solution like this that's secure, or you have to hard code your private information into your work, which, you don't want to do. So that's worth knowing about. If I go up to this one, the top one, what it is it shows the different headers that are built into your notebook, and it's a clickable table of contents. There's a search pane where you can find and replace. There is a code snippets pane that lets you browse through the code blocks, the cells that run. There's a files, so you can upload files, or you can actually download or upload a GitHub repository with all the files therein, so you can actually see. And you notice it just popped up that my memory has connected to my Google my Google Drive. So you can do something called mounting your Google Drive. You can do it by clicking this button. I'm not going to do that right now. It may ask me to do it if we last that long, which I'm worrying that we're not going to last that long now. But you can mount that and upload stuff from your Google Drive. You can also hide this and do some other things. And then finally down here, there are data sets that you can search for to work with that are just open data sets, and you can add your own to this as well. It's really cool. Guys, I'm getting that feeling where even with the best of intentions, I knew this was an iffy thing today, having gotten very late access myself. So we're going to put a pin in this. Do let me know if you want to try to attempt this again, and we'll just start coding from the beginning of the hour, and maybe I will edit the notebook and make it in a form that we can follow. But this is a normal part of the process. It's made much easier for non-coding folks with the addition of the AI built right into Collaboratory. Hope this was interesting, and I hope you can see the potential for this. And I got to go. I'm going to go downstairs. Happy Christmas to everyone. I've had so much fun over the past couple of weeks coming back and being able to start up again. And it's just great to see everybody. And I'm looking forward to the new year. So happy new year as well. And I'll see you all then. And if anybody wants to reach out through WhatsApp, not through email. I'm probably going to ignore my email flatly for the next several weeks. So happy new year and happy Christmas.
Yeah.
I'll see you later. Thanks for coming.